plutonium-239 has a half-life of 24,110 years. How long does it take for a 1 gram sample of plutonium-239 to decay to 1.1 gram? Okay, so what is half-life? Can anybody explain it to me? The amount of time it takes for half of a substance to decay. So we use this a lot with carbon, because carbon's found in our bodies. So in any living organisms, the more you decay, the more like carbon you have. So if you have a fossil, so think about the fossil, the imprint it leaves. Let's say that there was a little tiny bit of that organism that was left. The carbon was still in there. Well, you can tell the rate that carbon decays by its half-life. And so if you can tell what percentage of the organism you have, which is pretty easy to do because there's like a little skeleton shape in there, right? Then you can tell how long that organism has been fossilized. So you can tell how old it was. All right, so that's why it's really useful to talk about half-lives. Okay, so for this problem, I'm going to break it up into two parts. I'm just going to talk about the half-life, and then I'm going to do the second part. So the half-life is equal to 24,110 years. So that's my first part. So these always are your A of t equals p times e to the RT. Okay. So I don't care how much I start with. Let's not even pay attention to the 1 gram sample. Let's just say we start with p, so amount p. E is a number. I'd never plug anything in for that. R is what I'm trying to find. In time, it took 24,110 years for it to decay to that. So it took that long to get half of what you started with. So what am I going to put on the left side? 1/2 p. If I start with p, I'm going to have 1/2 p over here. And that's how you're always going to start out these problems. So that's half of what you started with. You don't have to write all these notes. I'm just writing them for you guys. Okay, so when I divide by p, you see what happens every single time? The p's are going to cancel. So I'm left with 1/2 equals e to the 24,110 r. And I need to solve for r. So my variable is an exponent right now. So how am I going to get rid of e? No?
1/2.
What cancels with e?
Log.
Natural log. So let's do natural log of both sides. That's log base e. As soon as you take the log of one of the sides, you can pull the exponent to the front. So this exponent's now going down, and the natural log of e is just 1. Log base e of e. So that's gone. So I have natural log of 1/2 equals 24,110 r. So that means r is equal to natural log of 1/2 divided by 24,110 r. Or not r, just 110. Okay, so find what that is. So do natural log of 1/2 divided by 24,110. Okay, I get a number in scientific notation. It's 2.875 times 10 to the -5th. Okay, the easiest thing to do is to go ahead and keep that in your calculator. You're going to use it for the second part of the problem. Okay, but if you're scared that you're going to lose that number and you need to do some computing between, there's actually a trick you can do on your calculator. So we do this in my calc class all the time. So you guys looking? So look back here. So do you guys see along the side? You see where it says STO? That's how you store numbers. So STO. So look for a button that says STO with a little arrow. So if you hit the store button, it says answer and then it has an arrow. Let's store that as a letter. So if I ever need to go back to it, it's stored as that letter. So let's do alpha, and then you can use any letter you want. So we'll call it A. And then hit enter. Anytime you want to talk about that number, it's now in your calculator as A. Okay? So you can always just use A over and over. It just keeps replacing whenever you store. All right, so we stored this as A, just in case I accidentally hit clear or whatever, it's in there. So now when I'm doing the rest of my problem, so here's the second half. They're long ones. All right, now I'm finding how long does it take for a 1 gram sample to decay to 0.1 grams. So that means if I start with my A of t equals PE to the RT. It's R. It's not a very good R. Okay, so I have my initial amount was 1 gram. My R is now stored as A. So if you just want to write A there, I'll know what that means. Or you could just write out negative 2.875 times 10 to the negative 5. It doesn't matter. I'll write it as the actual number. And then it decays to 0.1 gram. That's your amount. So I have 0.1 equals 1 times e to that rate I had times t. There's a t up there. All right, so now when I divide by 1, it's still just 0.1 equals all that. So how am I going to solve for t? Yeah? Yep, you're going to do natural log of both sides. So you're going to have, if you want to be lazy, you can just write natural log in front of both. Natural log of 0.1, the natural log and e are going to cancel. So those are going to be gone. So I'm going to have natural log of 0.1 equals that rate I had before times t. So divide by that rate, which again, you can just keep writing a. I'll know what that means, as long as you wrote what a was, times t, or equals t. So then you can find that. So I still have it in my calculator though. So if you're really safe, if you're really careful, it's already in there. So I just do second answer, second and the negative sign. So I do natural log of 0.1 divided by second, the negative sign, it pulls it up. So I get t equals 80,091.686 years. So about 80,092 years. Pretty old. Daniel has $5,000 in his checking account, which earns 3.5% interest compounded continuously. So whenever we see continuously, that's our A of t equals PE to the RT. So it says, what is his total amount of the investment after 3 years? So your amount after 3 years, you started with 5,000. Your rate is 3.5%, so 0.035, and your time is 3. So again, when I put this in your calculator, do e raised to the 0.035 times 3. Put it all in at once. What'd you guys get? 3.55. You get that? Yep, all 5s except that 1 3. Okay, then the question is, how long would it take for his investment to double? So in these problems, it actually doesn't even matter what he started with. You were given that he started with $5,000. So when you're talking about it doubling, your amount would be 10,000, right? But I think one year I put this on the test, and I didn't give you an initial amount. I didn't say he started with $5,000. And so everybody freaked out. They had no idea how to solve it. But you guys see if you put P there for the 5,000, what's the 10,000 going to be? Yeah, this is 2P. So it doesn't matter what he started with. It's always going to be twice whatever this was. So when you divide by P, they're gone. So it actually doesn't even matter. Okay, so I get, when I divide by 5,000, I get 2 equals e to the 0.035t. I need to get rid of my e, so I'm going to do natural log of both sides. Natural log and e cancel. So I get natural log of 2 divided by 0.035 is equal to t. Okay, so I got like 19.804, so about 19.8 years. Okay, it's almost 20 years. All right. Let's go ahead and do the last one too. Let me see where I am at the time. Ah, we have time. Okay. Okay, this is another half-life one. So it says a paleontologist uncovers a fossil of a saber-toothed cat in California. He analyzes the fossil and concludes that the specimen contains 15% of its original carbon-14. Carbon-14 has a half-life of 5,730 years. So start out with that. So half-life equals 5,730 years. So that's all you need to know for this first part of the problem. Okay, so when I start my problem, I'm going to start with P. Oh. So I'm going to have my amount after time t equals P e to the RT. So if I start with P after that many years, how much would I have over here? 1.5 P, right? Our rate is what you're trying to find, and the amount of time was 5730. Okay, divide by P on both sides. So the P's cancel. So I get 1/2 equals e to the 5,730r. So take the natural log of both sides, so I get natural log of 1/2 equals natural log of e to the 5730r. So natural log and e cancel. So I have r equals natural log of 1/2 over 5730. So I just divide by the 5730. Okay, you can find what that is. So I get negative 1.2096 or 97 times 10 to the negative 4th. You can store that if you're scared you're going to lose it, or just keep it in your calculator for the second part. So the second part says it contains 15% of its original. So if I started with P, what do I put on the left side of the equation? It's a tricky one. No. Your rate is still that. We're finding how long it takes to go to 15% of what you started with. So you can put numbers in. You could put 100 here and then 15 over here. It doesn't matter. But you're just going to have 0.15 P. You're going to have 15% of what you had when you started. So if I said 70%, you'd put 0.7 P. All right, so divide by P on both sides. So you get 0.15 equals e raised to the negative 1.2097 times 10 to the negative 4th t. So take natural log of both sides. So natural log and e cancel. So your answer, t, is going to be that natural log of 0.15 divided by that answer that's still in your calculator, negative 1.2097 times 10 to the negative 4th. So it's really important on these to not round, because if you round, you could leave off like 500 years, so you don't want to do that. So when I do natural log of 0.15 divided by answer, so do second negative to get your answer, I get 15682, so 15,682.813 years.